Hey guys, today we're going to be talking about section P.2, our preparatory chapter, or prerequisite chapter, section 2. And we're going to be talking about exponent properties and the rules that we've used in the past and making sure we're really keep them focused and make sure we follow the rules that we have. First, we have the product powers of a property. Don't get hung up on all the names. Just identify what's happening and make sure you can follow that procedure. Notice that the base here, it's the same. So it's a number times itself. Let's say 3 squared times 3 to the third. So the question is, what do you do with the exponents? Well, keep in mind 3 squared means 3 times 3. 3 cubed means 3 times 3 times 3. So really, I'm multiplying 5 3's here. And if you think about it like this rule says, we can add the exponents. 2 plus 3 is 5, making our answer 3 to the 5th. Okay, so when we're multiplying the same base, you couldn't do this with 2 cubed times 3 cubed. You couldn't just add the 3 and the 3. And I mean, what would your base be? Would it be 2? Would it be 3? Would it be 5? Would it be 6? We need to know that there's a policy here. So in these problems, it has to have the same base all the way through, okay? Then we have the power of a property, or power of a power property. So in this problem, we're really looking at the fact that there's an exponent outside of the parentheses. Now this is also important. There's no addition or subtraction in here. Okay? This is not x minus 2 cubed. That's not the same thing. Any addition or subtraction messes all of this up. This has to be strict multiplication. And so if I had 5 cubed squared, okay, squaring something means multiply it by itself, which makes this 5 cubed times 5 cubed. But we just said up here that when we have the same base, we should add those exponents, making this 5 to the 6th. Well, rather than write this out every time how to do it, I'm looking at this 3 and the 2, and I'm saying, hey, if I multiplied those, I get 6. So, same base multiplied, we add the exponents. One base with 2 exponents, we multiply the exponents. Then we get to the power of a product property. If you have two things that are being multiplied, like 4 and x, and you want to square them, you can square them individually. Notice a to the m, b to the m. That'd be 4 to the second, x to the second. Because really what you're doing is you're taking 4x and you're timesing it by 4x. Well, 4 times 4, that's 4 squared. X times x, that's x squared. So this is really 16x squared. But the key here is that everybody gets the exponent. A lot of times in questions like this, people will forget to square the number in front. They'll get 4x squared, and they'll forget that the 4 has to be squared as well. So please keep track of that. The next property is the negative exponent property. Anytime you have a negative exponent, we need to change it to positive. We'd rather have a positive exponent. So let's say that I have 5 to the negative 2. Well, according to this rule, it says that's the same as 1 divided by 5 to the positive 2. See, this was in a numerator before, right? It was over 1. Well, when the 5 to the negative 2 dropped down into the denominator, its exponent changed to positive, and that becomes 1 over 25, of course, because 5 squared is 25. But I want to point out that if you had something like 3 over x to the minus 2, okay, sorry about the handwriting, but in order for the negative 2 here to change, it would have to move upward. So we would then have 3x squared. So 3 divided by x to the negative 2 is the same thing as 3x squared. Notice the 3 didn't have a negative exponent, so we did not move it. We only move the things with the negative exponents. The next property is zero exponent property. Anything to the 0 exponent is going to equal 1, unless that thing is 0. So 0 to the 0 is 0. That's just, well, you'll never see it. But something like 5 to the 0 or x to the 0, they all equal 1. So it's sort of a default for us. The next property is that we can, when we were multiplying a by a, we added the exponents. So now when I'm dividing a by a, I should minus the exponents. So if I had 5 cubed over 5 squared, I'd minus 2. And down here, 5 to the 0, we just said was 1. And on top, we get 5 to the first. 3 minus 2 is 1, and that just turns out to be 5. And then down here, we have the power of a quotient property. It's the same thing as this property here that says I can distribute the exponent through a multiplication problem. It says I can distribute the exponent through a division problem. Okay, and so those are our properties that we're going to work with. Most of your homework's going to be working with those properties and how they affect numbers. The next thing we need to talk about just briefly is scientific notation. Scientific notation is about identifying small shorthand ways to write really large numbers. This times 10 to the 7th. Times 10 is just going to move the decimal place because we use a base 10 system. And this tells me to go 7 spaces to the right because it's positive. Over here, where it's negative, I'm going to go to the left. So here that would make it 2, 6. That's the first move, right? 1, 2, 3, 4, 5, 6, 7, and put the decimal. Put some commas in there to organize, and it turns out to be 26 million. Here, I need to move 1, 2, 3, 4, 5, and then put zeros in there. So it looks like I need 4 zeros. So let's go 0.1, 2, 3, 4 zeros, then 84. So those would be our expanded versions or decimal versions. Well, can we take decimals and put them back into scientific notation? This is where kids tend to have a lot of issues. So what we're going to do is we're going to figure out 1, 2, 3, 4, 5, making it 3.17 times 10 to the... Now we have to decide, is it positive 5 or negative 5? If I want to turn this new green number back into the original, I would have to move the decimal to the left. So I will use a negative 5. And over here, there's 3, 6, and 9. So 9.41 times 10 to the positive 9. Because if I want to move this green number to the original, I have to move it 9 spaces to the right. Now, a scientific notation that you're going to see on your calculators is very similar. It's going to say 3.17, but it will use a capital E and the exponent they want you to use. You'll see that on your calculator, and I don't want you to get hung up on it. It won't use times 10 to the, it'll just replace it with the letter E. And so these are simpler versions even of the scientific notation that are getting commonly used because of calculators and new technology. Last, just understanding a couple of things that we can do. We can group, if we're trying to do a division like this, or even multiplications, we can split the scientific notation into its times 10 pieces and to the number piece that sits in front. So 4.8 divided by 2.4, well that's 2. And 10.6 divided by 10.2, or 10 to the 6 divided by 10 to the 2. Remember we said we can subtract the exponent. So this is 10 to the 0, doesn't matter. 6 minus 2, 10 to the 4th. 2 times 10 to the 4th. Hopefully that's enough to get you through your homework and you can ask questions in class. Good luck.